Solutions to perfect problem 4 from Math 251. We're told that the derivative of sine is cosine, the derivative of cosine is negative sine, and from that we want to figure out some other derivatives. Derivative of tangent, for example. Maybe you remember from Math 1:12 that the tangent is the same as sine divided by cosine. And if so, then we can use the quotient rule. Maybe I should write the quotient rule off to the side in a different color. What the quotient rule says, maybe in shorthand, is that the derivative of a function divided by another function is the derivative of the top times the bottom minus the derivative of the bottom times the top, all divided by the bottom squared. So applying that quotient rule here, where f is sine and g is cosine, what we get is, maybe I'll write it out a little bit more. It would be the derivative of sine times cosine minus the derivative of cosine times sine. And that is all divided by cosine squared. But the derivative of sine is cosine. So cosine times cosine is cosine squared. And the derivative of cosine is negative sine. So minus negative sine squared is the same as plus sine squared divided by cosine squared of x. So now we've taken all the derivatives, but we haven't gotten a secant squared of x. The reason we haven't is because we haven't simplified this enough. Again, from 112, sine squared plus cosine squared is equal to 1 for any angle x. So this right here is just 1 over cosine squared of x. And maybe you remember that 1 over cosine is secant. So what we get is that the derivative of tangent is secant squared. All right, we can do something similar down here to figure out the derivative of secant. All right, the derivative of secant, let's see, secant is 1 divided by cosine. So if we apply the quotient rule that we got up here, the top function is just 1. The derivative of 1 is 0. So you get 0 times cosine of x minus derivative of the bottom, derivative of cosine. Let's see, maybe to really emphasize what I'm doing here, instead of writing a 0, I'm going to write the derivative of 1 times cosine minus the derivative of cosine times 1, all divided by cosine squared. So that's just using our quotient rule here. And now the derivative of 1 is 0. 0 times cosine is 0. And the derivative of cosine is negative sine. So negative sine is positive sine. So we get to here. We're done with taking derivatives. It doesn't quite look like our answer, but if you use some trig identities, this is the same as sine of x divided by cosine of x times 1 over cosine of x. So instead of cosine squared, I split it up into 2. But sine over cosine is tangent, and 1 over cosine is secant. So I get secant of x times tangent of x, which is good. That's what I was supposed to get up here. Use your answers to question 1 to find the second derivative of secant. Okay, so what I want to do is take the derivative of secant. The derivative of secant I just figured out, I think, right? Yeah, I figured that out up here. That's the same as figuring out the derivative of this inside right here is secant times tangent. Now we got to take the derivative of something times something. We have to use the product rule. What the product rule says is that the derivative of the product of functions is f prime of g plus g prime of f. Similar to our quotient rule up here, except now we're adding instead of subtracting and we got nothing to divide by. So here is our product rule. Applying that product rule on this mess right here, what we get is it's the derivative of the first one, derivative of secant times tangent, plus the derivative of the second one, derivative of tangent, times the first one, secant. And these are all things we know. The derivative of secant we figured out in 1b. That is secant times tangent. I'll leave the parentheses up to emphasize where stuff came from. And the derivative of tangent, we figured that out too. That's secant squared. So we got secant squared of x. And then this secant right here. So what we get for our final answer is secant of x times tangent squared of x plus secant cubed of x. Or if you really want, you could factor out a secant of x from both of them and write this as secant of x times tangent squared of x plus secant squared of x. Kind of feels like this should simplify to something, but but this isn't a 112 class. I don't know if it does anyways. Nothing jumping out to me anyways. But I just leave it like this. It's not a 112 class. We don't have to mess with trig identities all day. It's a calculus class. We took the derivative. We're done. That is the end of this perfect problem.